How many of you have actually heard of Ampere computing? Okay, the ShapeBlue team, and nobody else. And that is perfectly okay. I am to be blamed a little bit of my own company. How many of you have heard of Intel and AMD? Okay, great. I was ex-Intel, by the way. I might have to go back there if next year this thing doesn't change, right? But we are here to change that. So what does Intel and AMD do for the people in this audience? Yeah. So Intel and AMDs are the CPU companies for the world, for the server side, right? I'm restricting it to the server space. Ampere is a server CPU company. Let that sink in for a second, right? It's a server CPU company. We are a different architecture. Okay? Intel and AMD are x86, as we popularly know them. When you're downloading a binaries and things like that, it's x86. Ampere is ARM based. And it is quite interesting that I'll actually have to advocate a little bit of ARM, which we don't get paid for, but so that it, it's easy for you guys to understand, right? And I'm taking the privilege of being in Delhi, so I'll mix a little bit of Hindi in the middle, and we can have this conversation, right? Okay. Yota is trying to sell me their free Wi-Fi. Okay. So how many of you have heard AWS Graviton? Okay. For those of you who don't, AWS Graviton is the ARM-based silicon that AWS makes themselves. For Intel and AMD, they buy it from Intel and AMD. Okay. We are the AWS Graviton equivalent for the rest of the world, including all the other hyperscalers, that is Azure, Oracle, Google, the Chinese hyperscalers. And my goal is to make sure that is the case in India as well. Next year, if we happen to be doing this summit in Yota, and if they don't have an Ampere instance, I am to be blamed, right? That's the goal. Now, let's move on. A little bit about myself. I've spent all my life in Silicon, ex-Intel, decade and a half there. Now I run Ampere business. Now I'm trying to compete with them. A little bit about Ampere. It's Santa Clara headquartered. So we're in the same vicinity where you have Intel, AMD, NVIDIA, all of that. You throw a stone, it'll either come and hit us or it'll hit NVIDIA or the likes, right? It's all in the same sort of vicinity. In India, we have two R&D centers. One is in Bangalore, one is in Pune. But these are guys who are deep into the silicon stuff. They don't quite interact with customers and all of that. That's my job. Okay, when is the time to change? Today. Okay, I'll be skipping over some of these marketing slides, okay, so that we can keep some time for fun. All right, so now that I've pitched to you guys that we are a server CPU company, and server CPUs even from Intel and AMD are equally boring, so is ours, right? Because think of this for a second. How many of you have smartphones? Okay. How many of you really know the silicon of your smartphone? It runs on the silicon. There is no way it does anything else other than the silicon, right? I mean, you cannot remove that part. For once, you can remove half the memory. It will still work. But you cannot remove the silicon, right? It's like the engine of a car. When you're going to buy a car, most people go and buy the fanciest looking car, but they don't, I mean, unless you're a nerd, right? You'll be like this much BHP and that and this. So it's a slightly boring topic. But I'll try and keep it, as I said, at a high level. That's the reason I'm not getting into the gory details of all of this. But some important things for you guys to notice is what the world already had two server CPU companies. Why is the need for a third company? Of course, we want to make money. That is our problem, right? But what does it bring to you guys, right? So we solve for the power problem, okay? How many of you are old enough to understand and see when Mr. Ratan Tata actually was launching the Nano? Right? It was an ambitious project. People have all kinds of views about it, but just think about what he was trying to solve, right? An efficient vehicle. It didn't fly, that's a different story. We are trying to do the same thing, but don't think we are cheap or we are not performant or whatever. I'm going to break that myth. But it is basically to say that can we have more efficiency? And by more efficiency, I essentially mean have equal or better performance than x86 and be able to consume half the power, right? And fundamentally change the architecture of how things are consumed on the silicon side. ठीक है? By the way, किसी को भी कोई question हो ना तो बीच में ही हाथ ये कर लेना. I'm okay to take a little pause and answer that question, right? Happy to do that. Don't wait for the mic. Just stand up, ask, we'll talk. No big deal. Okay, let's talk a little bit about Ampere CPUs, what we are delivering today, and what our broader roadmap is. We give our first generation CPU, which is available on all the hyperscalers, and now we are going to the rest of the world, is basically 128 cores, single threaded. Allow me a moment and I'll explain what single threaded is. 128 cores, right? Single threaded, and consumes 178 watts of power. Make note of that. 178 watts of power. A typical machine of that size and that performance on the x86 world is going to consume at least 450, 350, you name it. Okay? So we are consuming half the power. It's like telling, I am going to give you a BMW, but it's going to give you 35 average. How does that sound? Right? And there is a need for this today. The kind of compute that is getting consumed, and Sunil kind of mentioned about that in the morning a little bit, the scale at which AI is moving, at the scale at which your regular compute needs are moving, you will run out of power. I was traveling on Tuesday, I think. I think it was either Tuesday or Monday's paper. Look up the Himanshu Lochab has put a nice little thing which says today all the data centers consume power equal to that of the entire country of Japan. Okay, by 2030 it will be like data centers are consuming power of 5 developed countries, and that's a big deal. Don't underestimate that. Okay, so we're trying to solve for that, but we cannot be doing some of those things where somebody says, oh, you consume less power, so you'll be doing less performance, right? That is not acceptable. Okay, let's take another real world example. And as I said, I'm here to tell stories, not to really, anybody who's interested in knowing the details of the CPU, you can come and talk to me separately. I'm happy to spend hours, right? When a new iPhone comes each year, right, what do they advertise? Chip, M4, M5. Yeah, that's on the laptop side. On the, okay, you guys got too serious about this. Huh? I think so. Yep. Thank you for that suggestion. The reason they tell you A16 CPU or M4, M5, half of the people cannot imagine what that really is. They just think that this is the newest one, so go buy, right? So that's one part. The other thing they always advertise is, oh, this is going to give you 20 hours of phone backup or phone battery power and things like that. That's another important thing, right? Guess what? Any high-end phone, be it Apple, Samsung, this, that, is always on the ARM architecture. Okay? So think of it this way. We're taking the same technology and now making server CPUs out of that. Okay? There were two companies. One is AWS, which did Graviton, and it was Ampere that we started in about the same time, and we went to the rest of the cloud. Obviously, we will have a hard time selling this to AWS guys, right? The internal scoop is that they really love our CPU even better than their Graviton, but we'll leave it at there, right? That's just a thing. I mean, maybe our marketing guys just made it up. But The story I'm trying to tell is that we are in the rest of the cloud and selling to a hyperscaler cloud, your CPU needs to be really, really, really validated. You cannot get past their gates by just fluking your way through. Are we on the same page? Okay. Now let's talk a little bit about my favorite subject. Why are we better? We give you better performance, we give you better scalability and efficiency. All marketing terms, but I'll explain how and I'll show you some real numbers as well. One thing, how many of you have heard this term called hyperthreading? What does it do? Anybody? I mean, somebody has to answer this. नहीं बगैर मतलब hyperthreading के बगैर भी virtualization चलता है. So I mean, while that could be one of the things. So let's understand this, right? If a CPU is 32 physical cores, when you turn on hyperthreading, the OS is going to detect that as 64 cores, right? So what is that basically is to say there is one physical core. That is the one that is doing your actual job. That's like the engine, right? And there are two threads. So it was bought as a technology when the CPUs used to be 4 cores, 8 cores, 16 cores, and 24 cores. I've lived through that era in my Intel times and even AMD and all that. It's a great technology, but it's run its course. I'll tell you why it's run its course. Now, if you have a problem, you have enough cores to throw at it. We are starting with 192 cores, 128 cores. We are already delivering 192 cores. And guess what is the size of our cores in the next generation? Anybody wants to take a guess? This is public information, so I'm okay to share. One CPU, how many cores are we going to deliver in 27 time frame? Take a guess. क्या जाता है, right? 512. 512 physical cores, single socket, and not using liquid cooling. Remember, that is the other fancy thing that is going to be a very heavy burden on the industry. Okay? आप CPU के server वगैरह खरीद रहे हो और साथ में आपको एक swimming pool भी खरीदना पड़ रहा है, right? Because you have to dip the servers to cool them off, right? Which is fine. I mean, the world is moving in that direction. I'm not saying it's great technology. I mean, imagine a digital device actually going there and all that. I'll keep a little this on the time. Okay, so we are single threaded. That essentially means every core is only one thread. There is no hyperthreading, and this is by design, right? When I told this story to my customers, they said, "Nahi yaar, we are used to hyperthreading. Hyperthreading to hona hi chahiye." I said, just wait, because the world is changing. The proof is in the pudding. Today, Intel and AMD, my counterparts will go and argue the other thing, but only if they realized that in their roadmap today, Intel Sierra Forest is all single-threaded. AMD Turing is all single-threaded. Okay, so they are giving you options of single-threaded and hyper-threading. We are only doing hyper-threading. We think in another 4 or 5 years' time, this single-threaded thing would have, so hyper-threading would have run its course, and the world will move towards single-threaded. Why do you need hyper-threading when you can have 512 cores on a single socket? Right? We provide larger caches. These are CPU details. If it's boring, just deal with it, right? We have larger caches. Our caches are double than that of x86, typical x86 CPU. Our L1, L2 is both the L1 instruction data and L2 and all are essentially double. That gives us enough and more amount of this thing and consumes less power. Okay, so because of our architecture, this red line here is basically suggesting our latency. So for those guys who care for 99.9 percentile latency, you need to try out our CPUs. Okay, this when you actually look at the performance of an x86, that is how it will behave. It doesn't matter which generation, and the reason is very simple. This is hyperthreading actually killing it, right? It's killing it because you see those bumps, the gray area. That is all because the cache is getting evicted. In our case, you don't have to evict. So I'll tell you one high level way of thinking of hyper-threading. You have a car, you have two cars, right? उनमें इंजन नहीं है, इंजन कहीं बाहर रखा है. आपको जब ये कार चलानी है, इसमें इंजन डालो, इसको आगे ले जाओ. जब ये पीछे रह गई कार, उसमें वो इंजन निकालो, फिर से इसको लेके आगे जाओ. ये जो निकालना और डालने वाला कॉस्ट है ना, that is what is causing those bumps. It is basically called evicting the caches and things like that in x86. And you see that scaling there, because scaling is an interesting thing in the compute world. Everybody talks about it, nobody does it. Okay? You will actually see the Intel or AMD CPUs, basically the x86 architecture plateauing like this. There are amazing AWS papers. We've written some papers. We've actually demonstrated that also, right? So if you genuinely care for the performance of your this thing, try us out, okay? And I'm not saying just go blindly buy a bunch of Ampere servers and regret someday. Try it, and we'll talk about that. So this is a little bit about our roadmap. I'll skip. I am on a timer. But our first family is called Ampere Ultra. What we are now delivering is Ampere 1, which is up to 192 cores. And there is another variant of 192 cores that is called the Ampere 1, which basically has additional memory channels, etc., etc. And you can see the usage power, right? Okay, some of the workloads that we work on is web services, modern databases. So CloudStack is like a great partner for us. We've done a bunch of papers with them. As Rohit mentioned in the morning, there is support for multi-architecture already in 4.19, but in 4.20, I believe we are going to become first-class citizens in CloudStack, right? So that is our aim, and I think we are very excited about the future. I can tell you some of the things, right? There is a customer who's trying to do some surveillance solution, very similar to what Yotta also offers. They were also trying to use NVIDIA, and there is an X cost to NVIDIA, but NVIDIA gives you great, mature software stack and all of that. All kudos to them, right? I mean, वो अलग बात है कि हम लोग की तबीयत थोड़ी खराब हो रही है because each time you see NVIDIA's this thing going up, you're like, oh shit, what's happening, right? Because eventually they're eating into your lunch, whether you admit or not, okay? That said, we were able to deliver a similar solution, right, at 30% the cost. Let that also sink in. 30% the cost of a surveillance solution, which in India has massive potential, right? The governments basically are now saying that every platform is going to be surveilled. You cannot have a rogue actor going here and there, you know, by doing whatever. Indian Railways is also considering actually surveilling every bogie, right? I mean, some might argue the privacy things, but leave that aside. From a technical solution point of view, you need something which is power efficient, which is also capex efficient in the sense that it has to be affordable. So somebody will have to do some work, but you know, it is really exciting. And I mean, I heard some of the questions from the audience that you guys use MariaDB and this and that. Come talk to me, and we will actually tell you how MariaDB performs on us versus x86, right? Yeah.
So I have a question to talk about the database. So mostly the database companies cost their licensing on the core basis, and now you are saying we are drastically changing the number of the code.
Yes.
So it will affect our licensing and the costing of the database, and like VMware also started costing on the code.
Brilliant question. It is beyond my paycheck, but we are working towards it. So we don't support VMware today officially. Technically, there is nothing stopping us from supporting VMware. Like there is a project called Project Fling. In your whoever is a VMware expert can actually go look it up. You will find Project Fling. There's nothing stopping us. The only thing that is stopping us is how do we manage the licensing. You cannot be asking me 128 core ka license for this thing. So we are working towards it. Stay tuned. Look for the release 9, VMware 9.1 or something like that. And I think we'll have something for you guys. Similar stuff for some of the database guys, Oracle and all that. Larry is a very good friend of my CEO, right? We are working these things through. It takes time. Nobody wants to give up money, but somebody has to somewhere also, you know, realize that the world is changing underneath, right? So you cannot have the same licensing mechanisms. Okay, a little bit of on the performance side. You cannot have all of this without showing performance. So our 192 cores versus an AMD's 192 core and a Xeon. This Xeon part basically is only 144 cores because you don't have beyond 144 cores from them, and the other one is a hyper-threaded piece basically. The first line actually tells you performance per watt. Okay, like how much performance are you able to deliver per watt of energy that you're basically consuming. And the second one is basically going and telling you the sort of gray bars is how much power we consume. So you can see we are actually consuming much less power than how much we can. This is an example, and we are happy to share this with anybody who wants to actually know. We are showing you this gray bar here, and we've not taken Intel for the sake of simplicity. This gray bar here is an AMD part, and this is AMD's Genoa that we are benchmarking against. Those parts are mentioned below. So it's not like we take an inferior part from our competition and go and benchmark. You can see the solid bars are performance per watt, and the gray bars are performance, the actual raw performance. So we are actually beating them on applications like Nginx, Redis, Memcache, MySQL, blah, 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 right? So this is your actual performance, and we will stand by this. Similar on AI performance, AI thing, nobody believes in the world that you can actually do great inference on CPUs alone. Okay, there is a company in India called Zero. Have you guys heard of Zero? It's called Zero Labs. It's an IIT Mumbai company. They're doing fantastic job. Their life revolves around doing efficient inferencing on CPUs, and we are partnering with them, right? These guys are mathematicians, and they talk some stuff which not many of us get. I'll skip this. Teaser. How many of you have ever taken an Uber ride? Maybe usi mein aaya subah, right? Uber mostly runs on Ampere. Okay, and this is important. I can tell you a million other customers who run and use Ampere, but Uber is important because imagine the amount of scalability that happens in their workloads every single day. Morning may things peak up, in the daytime they go down. In the night, there is nobody who's taking a ride, right? Same with events. On a new year, it'll peak, this and that. We are able to handle all of that. Okay. Speaking a little bit about CloudStack, I think I mentioned about, and these slides are dated. Rohit might beat me up, but we'll update this in the next ones. We are very close partners with CloudStack and whatever else they do. We have a beautiful paper. It is a very detailed, long paper of how and you can go and use Ampere for your compute needs if you are a CloudStack customer, right? So, and we are going to update that with every release going forward. And as I mentioned, in 4.20, we are basically wanting to be the first class citizens there. Yep. Okay. How do you decide today whether I should work with Ampere or not with Ampere? One, of course, come and talk to me and I'll help you. But if your underlying operating system is anything Linux based, right? Anything Linux based, let me let you guys actually sink that in. Then we are good. That could be a paid Linux or Ubuntu or Red Hat, SUSE, FreeBSD, whatever. If it is Windows and VMware, we are still working out our licensing and all of those things. So just stay tuned on that. Okay, and then you care for these things. All of this is today taken care of. This is not an exhaustive list of software, but I just wanted to put it out there because a lot of people have this anxiety whether my software is ported or not, or whether that software is available or not, right? It is absolutely available today. Majority of the softwares or applications that you are used to are available. And I'm getting the red signal. So where do you get these CPU-based servers from? Your typical OEMs, right? So today you can actually get them from HP, Supermicro, Gigabyte, ASRock. We are working with some other partners. I cannot disclose that at this point. We are still a younger company. And going forward, we will have it from other vendors as well, right? So that's that, and that is my name. Okay, you can take a picture, give me a call me on a date. I'm very happy to, come and sit and grab a beer with you and discuss this endlessly till the time you are bored to death. Okay. Any final thoughts and questions? Any questions? एक तो पूछ लो यार, मतलब ऐसा, just for the namesake. I know. See, okay, what nanometer? Great. Our first generation was 5 nanometers. Now we are doing 3 nanometers, and the next one will go into is N3PE. We do it from TSMC, just like everybody else except Intel.
Sir, Intel और AMD में normally boards अलग manufacturer बनाता है और CPU अलग manufacturer बनाता है. Normally ARM में board और CPU एक ही chipset में.
नहीं, हमारा भी, हम लोग सिर्फ CPU देते हैं, बोर्ड वाले बोर्ड बनाते हैं.
तो उसको तो आपका भी अलग से socket layer होगा जैसे.
हाँ, LGA socket पे होता है. So we provide LGA sockets, and Supermicro can put it, and they can make the board. But yeah, you're right. Rohit.
Just a comment for you, Vinod. So I think back in some time, your colleague Pete gave us Ampere-based course to just sort of try out, right? And as part of ShapeBlue's demo cloud offering, we have two Ampere-based course where anybody can go sign up for ShapeBlue demo cloud, play with that. In fact, the support for ARM64 landed in CloudStack last year, in CloudStack 4.20 already. So we even support multi-arc Kubernetes, instance, everything. In fact, anybody who has even, let's say, a Raspberry Pi 4 or 5 can try that out with CloudStack. So thank you for the host.
Oh, I mean, and thanks for the plugin, right? So if you really want to try it out, it works. And I'll just elaborate a little bit on what Rohit mentioned about multi-arc. Multi-arc basically means that your database is, let's say, running on x86. You can continue to run that on x86 because you think that if you run it on us, the licensing will get tossed, and database is not a layer that you want to go, fiddle with some new architecture. Let's try out if you have a front end. Let's say there's an Nginx, right? Nginx is stateless. अगर फट भी गया तो क्या हो गया? भाई विनोद आपको झूठ बोल के चला गया था, आपने विश्वास कर लिया, लगा दिया, फट गया तो क्या हुआ? It is stateless, right? So we can have a same, or we can have similar cluster, like the same cluster where there is Ampere-based hosts running a certain amount of workload, and the x86 is running the certain amount of workload. We basically call it augmentation strategy. In technical terms, it's multi-architecture support.
One more question. Like, at the end of the day, costing matters, right? I mean, it's an investment which the CSP has to do. So comparatively from Intel or AMD, does your processor are economical, or are they on the same line, or they are on?
So the question is ARM-based solution economical, expensive, or whatever? Maybe it's coming from Apple, wala funda. But being here, it's difficult to answer. I will just put it this way, that we will be competitive. We are hungry for business, and that question essentially lies on my table here. Every time you want to do business, come to me, and I'm going to make sure that you get a deal that you will not have a problem as far as the costs are concerned. At the same time, I don't want you guys to start imagining that we are the cheapest platform on the this thing. We are not, because we deliver a certain value to you guys.
For that, can you show me a slide? I have to take a picture.
Oh yeah. Any final thoughts? वो question पूछ रहे हैं, मैं नहीं. We are US-based company. We have Indian offices, just like my counterparts at this thing. We have R&D offices here, and I run the business for India, Middle East, and South Asia. That's why I'm on the roll all the time. Yeah. Okay, one last question.
Hi, this is Praveen here. Actually, I tried out Graviton, tried some applications for Kubernetes, where I've tried out Graviton for reducing the cost. But though it supports Kubernetes clusters, there are some open source projects like Istio and some other things, okay, which are not supported, because of which I have to start using the regular ones. So, what is the strategy for you to work with some of the open source projects?
So, yeah, it's interesting you're saying you use Graviton and Istio. You should try Ampere-based instance on Google Cloud plus Istio, right? So those are nuances that they have to go fix. It's a software thing. That said, it's very different there. I mean, many a times it's a political question than a architecture question, right? So if you're doing something where you control the hardware, then I don't think that will be a challenge. And if it is, bring it to us and we'll fix it.